Okay, guys, we can start. Please go to the page 104. Page 104. The topic is equations with no solutions or infinitely many solutions. Example 1. Page 104. Example 1. Solve an equation with infinitely many solutions. For what values of x will the rectangle and triangle have the same perimeter? In the rectangle, you have one side with the value of x, and the other side, the largest one, is 2x plus 3. In the triangle, you have the same value for each side, 2x plus 2. You have the same value in each side of the triangle. So one way to solve this is draw bar diagrams to represent the perimeters. Then decompose and reorder the bar diagrams to solve for x. Okay, you have 2x plus 3, and in the other part, 2x plus 3. These are the two sides of the rectangle, the longer sides of the rectangle. The other sides, the smaller ones, are x, represented by the variable x. The other part is for the triangle. The part that says 2x plus 2 is for the triangle. You have 3 times this because a triangle has 3 sides. Later, you represent this on the bar diagram. You write it again. You you reorder. You write the two values for the x, the two sides of the rectangle, the smaller sides. So you add and you have 2 times x plus the number 3. And you do the same in the other part. You have 2x plus 3 and the 2x. At the end, you obtain, when you express this, that 6 times x is 6 times x. If you simplify with the variable, you obtain that 6 equals 6, and there are true for any value of x. So the equation has infinitely many solutions. Okay, why they say this in this part? Because the variable doesn't have a value. We didn't find a value for the variable. Instead of that, we have the same part, 6 times x for the rectangle and 6 times x for the triangle. But you cannot find a value, a exact value for the variable. When you have the same in both sides, you only simplify, and at the end, they obtain that 6 equals 6. So you can say that 6 equals 6 are true for any value of x. It doesn't matter the value of x, because if you replace the value in one side of the equation, you need to replace it in the other side of the equation too. And it's going to be the same result. Another way to solve it is write an equation to represent the equal perimeters. Then use inverse operation and properties of equality to solve. Okay, we copy. Okay, I'm going to solve it with you on the board. You have for the rectangle, one side 2x plus, it's 2, no, 2x plus 3 plus 2x plus 3. This is the other side of the rectangle, the side of the part of the top. You have the part below, 2x plus 3, and you have the part on the top. Remember that they are going to be equal in the rectangle. So plus x plus x. This is for the rectangle. Now for the triangle, I'm going to copy down here on the triangle because I don't have much space. 2x plus 2, in this case I think that is 2, yes, plus 2x plus 2 plus 2x plus 2. This has to be equal at this other part. We can simplify it and later we equal the both parts if you want. 2x plus 2x is 4x, 5x, and 6x. 6x plus, now the numbers, 3 plus 3 equal 6. And this is going to be equal the part of the triangle. And now I'm going to solve the part of the triangle. 2 times x plus 2 times x is 4x plus 2 times x is going to be 6x again. 6x. Now I'm going to add the numbers. 2 plus 2 is 4 plus 2 is 6. 6x plus 6. You can see that we have the same value in here. So we need to find for what values of x will be 6x plus 6 equal 6x plus 6. We can simplify in here. If you pass the variable to the other side, 6x minus 6x plus 6 equals 6, you are going to eliminate this, right? Because 6x minus 6x, you can eliminate it. This is going to be 0. At the end, you only have that 6 is equal 6. When you when you are solving one equation and you find something like this, for example, 6 equals 6 or I don't know, 7 equals 7, you have this part that is equal to the other part of the equation, but you don't find a value for the variable. So you are going to say that this has infinitely many solutions because x could take any value, could be 1, 2, 3, 4, it doesn't matter. X could take any value and it's going to be the same. It's going to be the same result. Okay. We can go to the example 2. The example 2 is like the other examples we solved. It's to solve an equation with one solution, only one solution. Anna and Lee played soccer for the same number of hours, 1 week. How many hours did Lee play on Sunday? I have the Anna schedule and Lee's schedule. Anna is x plus 1.2, x plus 1.2, and in the 4 days, she has the same value, but Lee's schedule is different. It has x in the first day, 2.5 in the second day, 2x in the third day, and 4.5 in the fourth day. If you see the soccer schedule that is on the right part, you can see the days, Sunday, Monday, Tuesday, and Friday. These are the days they play soccer. And the number of hours that Anna used for this. This is the part you have at the beginning, right? The number of hours, 1.2 hours, 1.2 hours. The variable is x. The variable is x, so we copy the x in each value. But the number of hours is 1.2 for each day. And for Lee, we only know that we have x hours, 2.5 hours, 2x hours, and 4.5 hours. So using these facts, we write the equation. We already have the equation in the part that says another one. Write and solve the equation we obtained with the schedule for Anna and for Lee. So I'm going to solve the equation with you, but this is the equation we already solved in the last classes. We are going to obtain a value for the variable. We obtain only one value for the variable. It's 4 times x plus 1.2 equal x plus 2.5, x plus 2.5 plus 2x plus 4.5. 4.5. Okay. What we are going to do in this, the first part is to multiply the 4 that is affecting the x and is affecting the 1.2. How what is the result for 4 times 1.2? It's 4.8. Okay, 4x, 4 times x is 4x plus 4.8. 4.8 equal x plus 2.5 plus 2x plus 4.5. I only copy the other part because I solved for the 4 that is multiplying the parentheses. Now, what I need to do, remember, is to pass the variables for the to the other side. Keep the variables in the same side and the numbers in the other side of the equation. If I pass in here, I have 4 times x minus 2x. These are the only ones we have, yes. Now I have 2.5 in the other side. I'm going to copy the numbers. 2.5 plus 4.5 minus 4.8. Okay, when we solve this, what we have? 4 minus 1 is 3, minus 2 is 1. So x, 1x is equal, and we are going to add this. 2.5 plus 4.5 is 7, right? 7 minus 4.8, it's 2.2. We only add this and subtract the other one, okay? We only solve the operations. So we obtain that x is going to be 2.2. This has only one solution. This is the solution you have for this exercise. Only one. That is going to be 2.2 for x. Okay. You only find one value for the variable, so this is the only one solution, 2.2. We can solve the example 3. The example 3 is the different one. The important exercise you are learning to solve today is the 1 and the 3, because the example 2 is like the examples we solved yesterday and the day before and practicing last week. The important part in here is the theory that you are learning when we have many solutions or infinite solutions, when we don't have a solution for the variable, or when we have only one solution. Okay, go to example 3 in the same page, page 105. Solve an equation with no solution. Jill makes 3 bracelets and Mika makes 2 bracelets. They both use the same number of string colors. How many colors should they use to make the same amount of money? You can see at the right part that these bracelets, it's $5 per bracelet, plus another $2 for each string color. Bracelets by Mika is $3 per bracelet and $3 for each string color. Okay. We need to write an equation to represent this situation and then solve. We assign the variable x, we let x be the number of string colors, and we write the equation. Okay. Mika makes 3 bracelets, so that's the reason why I have three at the beginning, and it's multiplying 2, that is for each string color. X is the number of string colors, so 2 is multiplying the x, plus 5, that 5 are this $5 for each one, for each bracelet. And the same for Mika. You multiply 2 because she made 2 bracelets, and you multiply this by 3 for each string color, X is the string color, and you add the $3 that she gained for each bracelet. So we have the equation in here. Three times 2x plus 5 equal 2 times 3x plus 3. 3x plus 3. Okay, first step, solve the multiplication. The other one is the same. Okay. 3 times 2 is 6, and we only copy the variable, 6x, plus 3 times 5, that is 15, equal 2 times 3, that is 6x, plus 2 times 3, that is 6. We pass the variable to the other side. 6x minus 6x plus 15 equal 6. You subtract this, and 6 minus 6 is going to be 0, right? You have 15 equal 6. Okay, but in what kind of universe is this true? 15 never is going to be 6. They are different values, okay? They are completely different. So when I have something like this that it doesn't make sense, like in this case, you are comparing, you are saying that 15 has to be equal 6, but they are different. And you don't have a value for the variable because the variable eliminates when you have subtract 6x minus 6x. So this doesn't have a solution. You are going to write it because 15 can never be equal 6, so this equation has no solution. This equation has no solution. Has no solution because we cannot find a value for the variable. Okay. We have an example 4 in the other page, in the page 106. Page 106, we have another example. But in this is most theory, so I'm going to read it with you and explain if you need to explain something, but I think that you are going to understand. Example 4, determine the number of solutions by inspection. For example, how can you determine the number of solutions of each equation has without a solving? You can determine the number of solutions that the equation is going to have without the necessity of solve the complete exercise. For example, the first one, a x plus 3 plus 7 equal 2 times x minus 10 minus x. You add the numbers, 3 plus 7 equal 10, so you have x plus 10. Equal to the other side, you have negative 10, and when you subtract 2x minus x is going to be x, so you have that x plus 10 it's equal x minus 10, but they are not the same because in one you have positive for the 10 and the other side is negative. So you can combine like terms mentally. The equivalent expressions x plus 10 and x minus 10 are not true for any values of the x. In the exercise B, you can apply the distributive property on the left side of the equation mentally. It is easy to see that the equivalent equation 3x plus 12 it's equal 3x plus 12. It's true for all the values of x. So the equation has infinitely many solutions. Okay, it's like to solve the exercise, but you are solving the exercise mentally, okay? You don't need to write every step on the board. Only if they ask you just to know if the equation has any solution, many solutions or no solution, or the solution is only one value for the variable, okay? In the number 2, you can apply distributive property on the left side of the equation mentally, and you find that it's equal to the other side. So at the end, this has infinitely many solutions. Remember, when one side of the equation it's completely equal to the other side of the equation, so you say that it's going to be infinitely many solutions. Exercise C is the last one. You have 5x plus 8 equals 2x minus 1. 3x is going to be negative 9. You pass the 3 that is multiplying to the other side to divide, so you are going to obtain that x is equal negative 3. So how many solutions is this going to have? Only one solution. You can find the value for the variable x. You don't have any trouble in this like the other exercises. You notice that the coefficients of the variable terms are different. So when like terms are collected and combined, the result will be unique for the value of the x. We are going to obtain a unique value for the x. So in this case, this variable has a value, so we have a solution. We have only one solution. The equation 5 times x plus 8 equal to x minus 1 has one solution. You can solve the exercise that says try it and the part below. You need to determine the number of solutions each equation has without solving. We are only solve this by inspection, and you need to explain your reasoning. Why? Explain the reasoning. How did you obtain the result? That is, if it has many solution, infinite solution, if it has no solution or only one solution. You explain that. Okay, tomorrow, guys, we are going to work in the page 107, 108, and 109. I tell you this because if you want to start, we have the 110 too. We have the 110. This chapter of the book is one of the largest one, but you can see that it's easier. We solve the equations in the same way, only that we need to write if we have many solutions, we don't have a solution, or if we have only one solution. That's the only different part. Okay, so guys, I'm going to finish the class in here. So take care, have a nice day, and I'm going to see you tomorrow again. So bye guys.